Subscribe now and press the bell icon. Never miss an update.
Fast binary counters and compressors generated by sorting network. So in this we are designing binary counters and compressors which can perform the fast computation, and these designs are designed using sorting networks. So what is this sorting network? So sorting network means rearranging the elements which are given as input and produces some other sequences based on the inputs which we are given. So such networks comes under sorting networks. So like why we are going for binary counters and compressors, what is the need for generation of these binary counters means, in general for every arithmetic operations we include summation operations, which means addition. So addition of multiple operands in parallel affects the critical path of the design. So what is this critical path again? So the delay of the circuit from one input to the last output is called as critical path. So whatever the critical path includes in the summation of the multiple operands, as this critical path decreases, the output is achieved in a fast efficient way and the summation can be done in very efficient manner. So to speed up this summation, to speed up this addition, high compression ratio counters and compressors are designed. So to design these high compression ratio counters and compressors, when we involve them with conventional full adders which are designed based on these full adders, so these consumes more area and the speeds are limited when the number of bits in the operands increases. So in order to reduce the hardware complexity and in order to achieve the parallel computation, to increase the critical path delay to efficiency, the summation to be performed in a very efficient manner, so we have gone for the implementation of some saturated binary counters and compressors based on sorting networks. So first of all we will be looking for sorting networks, and based on the sorting networks which are available, we are going for the implementation of the counters. So like if we observe 3 and 4-way sorting networks, first they have given some order sequence. So whatever the sequence they have given, it is rearranged and the same number of inputs are utilized and some rearranged form of output is produced. So this is a 4-way sorting network and this is 3-way sorting network. So in general, what the basic element of sorter is a 2-bit input binary sorter. So whatever the inputs we will be producing, based on that the outputs are produced. So this thing is utilized in the 3-way and 4-way sorting networks also. Like if we in this paper we are mainly concentrated on 7,3 counter, 15,4 counter and 31,5 counters. These 3 counters are designed based on the sorting networks. So how these counters are designed? So whatever the input, whatever the counter size 7,3 means we are segmenting it into 2 different unsymmetric patterns. That is 7,3 means we are segmenting it into 4,3, and if we consider 15,4 means unsymmetric pattern which is 8,7, 31,5 means 16,15. So in such a way we are segmenting these counters into 2 different unsymmetric pattern, and whatever the unsymmetric pattern count we have considered, that much sorting network are built and those are utilized for the construction of those counters. For example, if we consider this 7,3 counters, so we have segmented into 4,3 counter, right? So whatever the sorting networks which we are utilizing, those are 3 and 4-way sorting networks. That 4-way sorting network, for example, if we are already discussed in the figure 2, that 4-way sorting network we will be passing the inputs and will be generating the outputs. So these sequence, based on these sequence, we will be defining a sequence which is the output of that sorting network is considered as reordered sequence, and to that reordered sequence we are giving a fixed 1 and fixed 0. So like that we are defining a sequence on that which 1, 0 means 0, 1 junction is formed. So based on this sequence we are generating a sequence based on one hot code generation circuit. Based on the AND operation we are generating different outputs, whereby complementing the one of the input to the AND gate when we are generating some order sequence based on the defined sequence. So this circuit is called as one hot code generation circuit. Based on this, why we are generating this means to simplify the output expressions of the 7,3 counters. So based on these outputs which are derived, we are trying to get some relations such that they can be utilized in the simplification of the expressions. So the final expressions for the 7,3 counter can be defined as this is the C2, one of the output for the 7,3 counter, and this is the simplified expression, and C1, and this is furthermore simplified expressions by utilizing the hard code sequences, and this is the sum operation of the 7,3 counter. So in such a way, by utilizing these all, we are trying to design a 7,3 counter. Whatever the inputs we are passing, that is segmented and given to the sorting networks, outputs are collected and hardcode sequence operation is performed, and Q, P are generated, and these are utilized to generate sum C1 and C2. So in the same way, how we have implemented 7,3 counter, we can go for 15,4 counter also. So the only difference is the sorting network length increases, and whatever the hardcode sequence generation outputs are there, those are increases, and the rearrangement of sum C1, C2 and C3 will be changes. So these are the general expressions for the 15,4 counter, which are S, C1, C2, C3, and based on this we are going for the implementation of 15,4 counter. So this H bus consists of the outputs from the H and I, and whatever the inputs are generated to the other gates, those are considered under HI bus. So in such a way we are generating S, C1, C2, C3. So what are these R and R1 to R8 means whatever the end operations in the C3 are considered as R1, R2, R3, Rn until R8. So these are considered as R values, Q values from the hardcode sequence of 7 sorting network, and H are the values from the 8 sorting network. So in such a way we are trying to design a 15,4 counter by deriving some expressions for sum, carry 1, carry 2 and carry 3. After this, by utilizing the same implementation for the 31,5 counters, the output expressions are given as S, C1, C2, C3, C4. So based on this, 31,5 counter is also designed. So after the designing of these counters, we are going for the compressor designs. So in general, whatever the compressor is there, it is designed by making use of 2 full adders. So the same thing has been done using sorting network by implementing a single full adder with a half sort network with some AND gate and OR gate. So in such a way we are trying to design a 4:2 compressor with a sorting network, and after that some approximate compressor with single error is generated using a 4-way sorting network, and the same thing has been implemented in somewhat by making some changes with the XOR gate by generating 4:2 compressor with 2 errors. So now whatever the counters and compressors are designed, these are implemented or these are tried in a multiplier circuit. So here there are some changes like this somewhat manipulated. So here we are trying to implement a 7,3 counter in an application of multiplier of 8-bit multiplier and 15,4 counter for 16-bit multiplier. So now where these counters and compressors are utilized. So as an application now only we have seen in the multiplier. So this can be applied to Mac applications, DSP applications, image applications, and whatever the arithmetic operations are there at such scenarios we can go for this circuits.